So this is the end of 6.3. It should be kind of tolerable or maybe even easy. We do these kinds of problems in intermediate algebra, so these might look familiar. You might already know how to solve them, which would be great. Each of the problems between 33 and 50 is called an exponential equation. The exponential part means there's an x in an exponent. Possibly there's going to be an x in multiple exponents. And the equation part means there's an equal sign. And anytime a problem has an equal sign and the variable x, you can get a numerical answer for the x, which can be checked. To solve the exponential equations between 33 and 50, the strategy that I'm going to do is I'm going to rewrite so that each side has the same base, and then I'm going to solve by dropping the bases and setting the exponents equal to each other. On your problem 33, on the left-hand side, the base is 3, and on the right-hand side, the base is 27. Each of the problems between 33 and 50 is set up so that it's going to be easy to rewrite each side as the same base, because one of the bases is going to be a power of the other base. Specifically in problem 33, if you look at the powers of 3, 3 to the first is 3, 3 to the second is 9, and 3 cubed is 27. So one of the bases, 27, is a power of the other base. When that's the case, exponential equations are easy-ish to solve. When we get a few sections later, I forget if it's 6.5 or 6.6, we're going to solve exponential equations where one of the bases isn't a power of the other base, and we'll have to use something different to solve those, but we don't need to worry about those now. So to get started in any of the problems in this section, you need to know what the bases are and how to rewrite one of the sides with the base that can make both sides written with the same base. And in my problem 34, the 16 is a power of 2. So to get started on 34, I'm going to write each side with the same base, meaning I'm going to rewrite the right-hand side so that it has a base of 2, because my left-hand side has a base of 2, my right-hand side has a base of 16, but 16 is a power of 2, so 16 can be written as 2 to some power. So now that I have each side written with the same base, the way we solve exponential equations is we drop the bases. So I'm going to kind of cancel out the bases or drop the bases and set the exponents equal to each other. And when I do that, I get a real easy linear equation to solve. And so I'm just going to solve for x, and I'll have an answer that I'm going to check. To solve for x here, I'll just minus x from both sides, and I'll get an answer, whoa, guess I'm not woken up yet today, of x equal to -1. So anytime we solve an exponential equation, it's not particularly hard to check, and some of the checking I'll do in my head, some I'll use my calculator. But to check, you take the original problem before we did any rewriting and take your answer and put your answer in for the x in this case, because the letter's x. And the only way my answer is right is if both sides come out to the same number. If I wanted to check this on my calculator and I didn't want to do any work in my head, on my calculator I'd type the number 2, I'd hit the exponent key, and I'd put the entire exponent -1 plus 5 in a parentheses. And what that's going to do is it's going to simplify the left-hand side for me. My answer is only right if it comes out to equal the right-hand side. If I didn't want to do it on my calculator, then by hand I can combine the exponents. Since the exponents have opposite signs, when you combine them, you subtract and take the sign of the larger, and then I can know that 2 to the 4th is 16 in my head. So this is kind of the by hand way to check, to show that my answer is correct because when I plug it in, both sides come out to the same number. And then the calculator way to check would just be able to go 2 up arrow parentheses -1 plus 5, and that would simplify the left side for me. There's no need to do checking by hand if it's quicker for you and more accurate on your calculator. When you get started on problem 33, your first step is going to write the left-hand side just how it's given, but you're going to write the 27 as 3 cubed, and then you're going to drop the 3's and set the exponents equal to each other. And then you'll have a really simple equation to solve. So 35 and 36, I don't know that they're infinitely harder. They're a little bit harder. For 35, the 64 that's the base on the right-hand side is going to be a power of the base 4 on the left-hand side. And for you to get started on 35, you have to be able to rewrite the 64 with a base of 4, and you're going to rewrite it as 4 cubed. For me to get started with 36, I have to know that 216 can be written as 6 to the 3rd power. So our first step in each of the problems between 33 and 50, unless they're kind of written so there needs to be another first step. My first step is to rewrite each side with the same base. And on the left-hand side, the base is 6. Because 216 is a power of 6, 216 can be written with a base of 6. And so now I have the problem written so that each side has the same base. And if I can write each side with the same base in an exponential equation, I can drop the bases and set the exponents equal to each other. And when I do that, dropping of the base, I might get an equation that's hard for me to solve. That negative x, you can rewrite it as negative 1x if you didn't immediately know how to solve negative x equal to 3. The way that we'd need to solve it, whether the 1 was or wasn't written in front of it, is to divide both sides by -1. When I divide either that version or this version of both sides by -1, the left side, the 2 negatives cancel and become a positive. The right side, I get -3. And I believe that's my answer. And again, I can check this by hand or I can check it on my calculator. So for the checking, I should use the original problem, 6 to the -x equals 216, and I should plug in -3 for x. So there's a negative already in the line above it, and I'm going to insert another negative by changing the x to -3. That's going to cause a double negative, and usually when there's a double negative, you separate those negatives with a parentheses. The double negative will turn positive, which will leave me 6 cubed equal to 216, which I know that's the case. So I've checked completely without my calculator, and that's generally how I'm going to check, but using your calculator isn't particularly hard. If on my calculator I wanted to check right there, I'd go 6 up arrow negative parentheses -3, and it'll tell me that the left side simplifies to 16. So just 6 up arrow negative parentheses -3. And it'll give me that the left-hand side equals the right-hand side when it's simplified. All right, so give 35 a go. The next 4 problems have fractions, and they're a little bit trickier. There's a couple ways to think about the fractions. And as I'm thinking about the way to do this right now, it needs to be, so on the left-hand side, the base is 1/3. On the right-hand side, the base is 1/27. It's going to be possible to rewrite 1/27 with a base of 1/3. That's being kind of clever, and it doesn't lend itself well to the other problem that we're about to do. So I'm going to make these bases so they're not fractions. and that's kind of a mess. The rule that I'm going to use to do this would say that 1 over x to the negative n, whoops, really not awake this morning, 1 over x to the n power equals x to the negative n power, which would mean 1 over 3 to the first power equals 3 to the negative 1 power. Would also mean that 1 over 27 to the first power equals 27 to the negative 1 power. So I'm going to use this strategy to rewrite the problem so that neither base is a fraction. I'm going to shove my work up here. So I'm going to rewrite the 1/3 x to the negative 4 as 3 to the negative 1 x to the negative 4. And I'm going to rewrite 27, 1 over 27, as 27 to the negative 1 power. This is good now because the base is 3 here and the base is 27. Those are nice because 27 is a power of 3. 3 to the first power is 3. 3 to the second power is 9. 3 cubed is 27. So now it's more clear that the right base is a power of the left base. But bad things have to happen here for me to get this simplified. So in order to get both sides with the same base and to get something that's solvable, I'm going to shove that 27 in a parentheses. 27 to the negative 1 power, 27 up arrow negative 1 power without a parentheses, math, enter, enter, is equal to 1/27th. And 27 to the negative 1 power with the 27 inside of parentheses is still equal to 1 over 27. When I rewrite the 27 as 3 cubed, that's going to cause my 27 to have 2 exponents that apply to it. I want to separate those exponents with the parentheses just to make it easier to do the math that needs to be done. So I haven't done much with the left-hand side yet, but I will in a second. So now I have both sides written with the same base, and each side has kind of 2 exponents that apply to the base. To clear those exponents, you multiply those out. So to clear the parentheses on the left-hand side, I'm going to multiply negative 1 times x and negative 1 times negative 4. That's going to make my exponent on the left-hand side negative 1x, because negative 1 times x is negative x, and then plus 4, because negative 1 times negative 4 is 4. On the right-hand side, I'm going to multiply the exponents of 3 and negative 1 and get negative 3, which will allow me to write the right-hand side as 3 to the negative 3. Now I have both sides written with the same base, so I can drop the bases and set the exponents equal to each other. So I'm going to drop the bases, set the exponents equal to each other. This gives me negative 1x plus 4 equals negative 3. I'm going to minus 4 from both sides. That will give me negative 1x equals negative 7. And then you divide both sides by negative 1. And I get my answer of x equal to positive 7 that I certainly should check. And I'm going to definitely use my calculator to check this one because it's not so fun to check. So for checking, I should take the original problem before I changed it at all, which was 1/3 to the x minus 4 equals 1 over 27. And I'm going to plug in 7 for x. So I'll get 1/3 to the 7 minus 4. That should equal 1 over 27. Before I use my calculator, I'm going to make it a little bit nicer. I'm going to make this 1/3 cubed equals 1 over 27. And then I'm going to check on my calculator, even though I could check by hand. To cube this, you'd cube the 1 and cube the 3. You'd get 1 cubed over 3 cubed, which is 1 over 27. But I'm going to enter this on my calculator because that's probably the way most students would need to do it. So on my calculator, I'm going to do parentheses 1 divided by 3 close the parentheses, and then take the exponent with an up arrow, and it's going to give me a decimal that I'm going to math enter to make into a fraction, and it's going to make both sides 1 over 27. It's going to make the left side 1 over 27, and the right side's already 1 over 27. So let me try to sneak that checking in here. So parentheses 1 divided by 3, up arrow 3, and then math enter. And so that tells me that the left side simplifies to 1 over 27 because the right side started off with 1 over 27. I know my answer is correct. All right, so I'm going to do something similar for problems 39 and 40. The nice thing about problem 39 and 40 is only one of the sides is a fraction. They're a little bit easier. So when I jump into problem 40, I'm going to rewrite the left side so that the base is not a fraction. It's not particularly hard to do. I'm going to use the rule that 1 over x to the n equals x to the negative n. And for this particular problem, this is really 1 over 2 to the first equals 2 to the negative 1. So that's the rule that I'm going to clean up the left-hand side with. So I'm going to rewrite the left-hand side. I'm going to leave its parentheses. I'm going to leave the exponent of 3x minus 4, but for the 1 over 2, which is 1 over 2 to the first, I'm going to change it to 2 to the negative 1 power. There's an implied exponent on that 1 that I inserted there that's not generally written. So now I have the left-hand side with a base of 2. I have these double exponents that I need to contend with, and I have the 32 that I haven't done anything with. And for the 32, it's easy. 2 to the first is 2, 2 to the second is 4, 2 cubed is 8, 2 to the fourth is 16, which you're going to need when you do problem 39, and 2 to the fifth is 32. I'm going to do two things on this next stage. I'm going to write 32 with a base of 2 because the right-hand side has a base of 2, and I'm going to clean up and get rid of the parentheses on the left-hand side by multiplying out the exponents. I'm going to multiply negative 1 times 3x and negative 1 times negative 4, which is going to allow me to write the left-hand side as 2 to the negative 3x plus 4. Now I have the problem written with the same bases, and you have an exponential equation with the same bases. You can drop the bases and set the exponents equal to each other. So I can rewrite this problem now as negative 3x plus 4 equals 5. I'm going to minus 4 from both sides, and I'm going to get a fraction answer. This is going to give me minus 3x equals positive 1. And then I'm going to divide both sides by minus 3, which is going to give me my answer. On the left-hand side, I'm going to get an x because the minus 3's are just going to cancel. And on the right-hand side, I already have something that's suitable for an answer. 1 over negative 3 would be fine to write to the right of this equal sign, but it's probably more natural, looks more like an answer if I bring that negative up to the numerator. So I'm going to say that's my answer, and I'm going to make a shot at checking it. To check this answer, I need to take the original problem, 1/2 to the 3x minus 4 equals 32, and I need to check it by going 1/2 to the 3 times negative 1/3 minus 4 equals 32. Before I get ugly on my calculator with the fraction with the ugly exponent, I'm going to simplify this exponent. I'm going to get this exponent down to a single number. I could do that in my head because 3 times negative 1/3 is negative 1. Negative 1 minus 4 is negative 5. But I'm just going to do that exponent on my calculator to get it simplified quickly. So 3 parentheses negative 1 divided by 3, which is that part of the exponent, and then minus 4. So I'm going to, after I hit enter, be able to rewrite the exponent much nicer than it already is given to me. So I can change the exponent to the number negative 5. And now on my calculator, if I don't know how to do that from my intermediate algebra skills, on my calculator, I can go parentheses, 1 divided by 2, parentheses, up arrow, -5. The exponent, because it's just a single number, doesn't need to be in a parentheses. So let me do that. 1 divided by 2, up arrow, -5. That's going to simplify the left-hand side to a number, and the number that it turns into is the number it needed to turn into, because for my answer to be correct, both sides have to simplify to the same number. Since the left-hand side was 32, right-hand side was 32, the left-hand side had to simplify that. There are certainly ways to simplify that by hand that we don't really need to know right now, and my videos get long enough, so sometimes I have to pick something to skip talking about. So your 39 should solve real similarly, other than you're going to have a 2 to the 4th over here as opposed to a 2 to the 5th. For your problem 41, the 25 on the right-hand side is going to be able to be replaced with 5 squared. And for my problem 42, the 8 on the right-hand side is going to be able to be replaced with 2 cubed. When I go to do my right-hand sides, and when you go to do your right-hand side, because there's already an exponent on the right-hand side and you're going to introduce a new exponent to the base, you should shove that base in a parentheses to make the algebra clearer to follow. So just like I kind of did on the last 2 problems with the right-hand side that had the -1 exponent, I took its exponent and brought it outside of parentheses. That will make it easier. Should be 2 to the 2x plus 1. That will make it easier when I do the next step of rewriting the base on the right-hand side with the base that the left-hand side has. Now I'm going to clear the parentheses that I have on the right-hand side by multiplying 3 times x and 3 times -2. That's going to make the exponent 3x minus 6. Now I have both sides written with the same base, and when you can get both sides written with the same base, you can drop the bases and set the exponents equal to each other. So now I'm going to go 2x plus 1 equals 3x minus 6, and I'm going to minus 2x from both sides to get the x isolated with a nice positive 1 in front of it. And then I'll add 6 to both sides. The x is on the right-hand side. That doesn't bother me. It's okay to have the x over there. The answer is going to be x equal to 7, or 7 equal to x, which mean the same thing. When I go to check, because there's x's on both sides, I need to check both sides as opposed to just one. So for the checking here, the original problem was 2 to the 2x plus 1 equals 8 to the x minus 2. I need to, on the left-hand side, plug in 7 for x, and on the right-hand side, plug in 7 for x. Eventually, I'm going to use my calculator. This side right here, its exponent is 2 times 7, which is 14, plus 1, which is 15. When I go to do my calculator, it's going to be easier to enter 2 to the 15th power. And for this side, I'm going to do the work to get the exponent down to a single number. When I go to enter this side, I'm going to enter 8 to the 5th on my calculator. So now it's just a matter of making sure each side simplified to the same number. The left side comes out to 32,768. The only way my answer is correct is if when I do the right-hand side, I get exactly that same number, and I do. So the beautiful thing about these problems is there's never a reason to write down a wrong answer, because it only takes a minute to check, maybe even less than a minute. But this stuff in red's completely optional. You don't have to check. (43) and 44 are going to work real similarly. When you attack your 43, the 9 on the right-hand side, you're going to replace it with 3 squared. And when I do my 44, the 49 on the right-hand side, I'm going to replace with 7 squared. Because I have the issue of the right-hand side's going to turn into something that has 2 exponents, I'm going to rewrite the right-hand side with a parentheses before I insert that exponent. You can do those both in one step if you care to, but I'd like to just separate my steps so they're easier to follow. So now I have both sides written with the same base. I'm going to clear the parentheses on the right-hand side by multiplying 2 times x and 2 times 1. The right-hand exponent now is going to become 2x plus 2. Looks like I'm going to get a fraction answer. Maybe not. I think so, though. Now that I have the bases the same, I can cancel out the bases and set the exponents equal to each other. So this is going to give me 4 minus 5x equals 2x plus 2. I'm going to get the x's on the right-hand side because that's going to make the x's positive by adding 5x to both sides. That's going to give me 4 equals 7x plus 2. Then I'm going to minus 2 from both sides, which will give me 2 equals to 7x. And then I'm about ready to get my answer. I'm going to divide both sides by 7. That's going to give me 2 over 7 equals to x for my answer. That's a horrible answer to have to check. But you really should, especially because I don't often give fraction answers. So anytime I get a fraction answer, I'm really worried that I made a math mistake, because more often than not, my answers are clean numbers. So to check, I need to take 2/7 and plug it in for x. So I get 7 to the 4 minus 5 times 2/7, yuck, equals to 49 times the 2/7 plus 1. Ew, that's ugly, but I'm just going to do this all on my calculator. For the left side, I'm going to go 7 up arrow parentheses 4 minus 5 parentheses 2 divided by 7 parentheses parentheses. And for the right side, when I break out my calculator, I'm going to go 49 up arrow for the exponent, and then the whole exponent needs to be in a parentheses, and that exponent is going to be 2 divided by 7 plus 1, close my parentheses. So I just put the entire exponent in a parentheses on the left-hand side for my calculator and on the right-hand side. So I picked up extra parentheses that weren't there already. So left side, 7 up arrow parentheses 4 minus parentheses, 4 minus 5 parentheses 2 divided by 7 parentheses parentheses, horrible number of 148.97 with a lot of stuff after it. The right hand side, I go 49 up arrow parentheses 2 divided by 7 plus 1 parentheses, and I get that same 148.97. So I know my answer is correct, so I can put a little check sign. You don't even have to write anything down by hand. You can do all the checking on your calculator just to convince yourself your answer is right. (45) and 46 are so easy they're hard. On 46, on the left-hand side, my base is e, which is the number 2.71828. And on the right-hand side, my base is e. So these problems don't need to be rewritten. They have the same base, and that's what my goal is, to have each side written with the same base. If each side is written with the same base in an exponential equation, you can just drop the bases and set the exponents equal to each other. And 46 is given to me with each side written with the same base. So the algebra that I'm going to do is I'm going to drop the bases and set the exponents equal to each other. To solve this, I'm going to minus x from both sides. And I'm going to emphasize on the right side that that minus x has an implied 1 in front of it. That's going to make the problem minus 5 equals 1x, or just x minus 4. And then I'm going to add 4 to both sides. And that's going to give me my answer. On the left-hand side, the numbers have opposite signs, so I subtract and take the sign of the larger. On the right-hand side, the 4's cancel and I have my x. For checking, I don't really need my calculator, but I will use my calculator just because it feels more convincing. So for checking, the original problem is e to the x minus 5 equals e to the 2x minus 4. The left side, it's e to the negative 1 minus 5. Let me do that real quickly by inserting the negative 1 minus 5 in a parenthesis. So I'll go second in ln for the e, and then negative 1 minus 5. So the negative I use down there, the minus is there. That's negative 1 minus 5. So the left-hand side comes out to 0.00248787. For the right-hand side, when I plug negative 1 in for x, you get e to the 2 times negative 1 minus 4. And that entire exponent needs to go in a parenthesis. So for the right-hand side, second in ln, and then 2 parentheses negative 1 minus 4. And then when I hit enter, I get exactly that same decimal, 0.00248787. So I know my answer is correct. I technically didn't need to use my calculator to check this, because if I would have worked my exponents down to single numbers, it would have been obvious that each side is equal to each other. If I simplified this exponent, negative 1 minus 5 is negative 6. If I simplified this side, the exponent would be negative 2 minus 4, which is another negative 6. So I could have checked it just like this, because this shows that each side simplifies to be the same number, even though I don't know the decimal equivalent to that. E to the negative 6 is equal to that 0.00 number. 0.00247 number. So your problem 45 should work the same way. We only have 2 problems each to do and 4 problems in the section. And each of these problems require me to remember a rule from Intermediate Algebra, and the rule needed for 47 through 50 says this: x to the m times x to the n equals x to the m plus n, which says if you're multiplying terms with the same base, you can perform that multiplication by adding the exponents and leaving the bases fixed. So the problem with 47 and 48 is that the left-hand side has 2 bases, and I need to rewrite the left-hand side with 1 base. On the left-hand side, the first term has a base of e and an exponent of x minus 4. The second term has a base of e and an exponent of 3x. So there's 2 bases that I need to get down to 1 base, and the rule says if you're multiplying terms with the same base, that you just leave the base alone, go from 2 terms to 1 term by adding the exponent. So I'm going to employ this rule right here. I'm going to rewrite the left-hand side with 1 base, and I'm going to add the exponents. Now I'm going to simplify the exponents a little bit. The left exponent, there's a 1x and a 3x that can be added. And when I add 1x and 3x, I get 4x. So I can rewrite this left-hand side as e to the 4x minus 4 equals e squared. Now the bases are the same. And when the bases are the same in an exponential equation, you can drop the bases and set the exponents equal to each other. Super easy to solve this. I'm going to add 4 to both sides and get 4x equal to 6. I'm going to get a horrible fraction answer, which is really unfortunate. Divide both sides by 4. I get x equal to 3/2. That's the best answer for test purposes. For calculator purposes, and I'm going to use my calculator. I'm going to change 3/2 into a decimal by going 3 divided by 2 and getting 1.5. I'm going to use 1.5 for checking because it's going to make it a lot easier, because there's a mess on my calculator with that fraction. So to check, I need to take the problem before I did anything. E to the x minus 4 times e to the 3x equals e squared, and I'm going to plug in 1.5. So I'm going to go e to the 1.5 1.5 minus 4 times e to the 3 times 1.5. See if that equals to e squared. And I'm going to enter these on the whole left side at once in my calculator, and the exponents need to go in a parentheses. So on my calculator all at once, I'm going to work on the left side, do second and ln, and then 1.5 minus 4, close out that, so that's the whole first e, then the time sign, and then second and ln, and then e to the 3, that says times 1.5. So the whole left-hand side's going to simplify to be 7.389. And I'm going to work on the right-hand side and go second ln e squared. And I get another 7.389. Because the left and the right side simplify to be the same number, I know my answer is correct. So your problem 47 will work similarly, and you're not going to get a fraction answer for your 47, so it's a little bit easier. 47 and 48, even though they have e's, the students would be less likely to make a mistake on them, because when you're using the rule to change the left side from two bases to one base, it's not tempting to multiply the e's. On 49 and 50, I'm going to use the same rule to rewrite the left-hand side, because the left-hand side has two bases, and I need each side to only have one base and not two bases. So I'm going to use this same rule, and it's going to be real tempting when I use this rule to multiply the 3's. But the rule that says if you're multiplying terms with the same base, you add the exponents and you don't change the base, will apply here to rewrite problem 50, and I shouldn't multiply the 3's together because the bases don't change, only the exponents get added. So I'm going to, in problem 50, I'm going to rewrite the left-hand side so that it only has one base by using the same rule that I used for the e's. The x to the m times x to the n equals x to the m plus n. In this case, my base is 3, and when I multiply terms that have a base of 3, I leave the 3 fixed and I add the exponents. So now I have the left-hand side written so that it only has one base, which is good. I'm going to simplify the exponent a little bit by combining the minus 2 and positive 4. Since those numbers have opposite signs, I subtract and take the sign of the larger. That's going to give me x plus 2. Now I have each side written with the same base, and when you have each side written with the same base, you can drop the bases and set the exponents equal to each other. And for an answer, I'm going to get x equal to 3, which I certainly can check, should check. It's not that hard to check. So for checking, the original problem is 3 to the x minus 2 times 3 to the 4th equals 3 to the 5th. I'm going to plug in 3 for this x and get 3 to the 3 minus 2 times 3 to the 4th equals 3 to the 5th. This I'm just going to write as 3 to the 1 times 3 to the 4th equals 3 to the 5th. I know that that's true because the rules of exponents tell me that this left side can be simplified by just adding the exponents. But I'm going to do it on my calculator because maybe that's more believable. On my calculator, I'm going to enter this because 3 to the 1st is 3. So for the left-hand side, I'm going to go 3 times 3 up arrow 4. The left-hand side is going to come out to 243. For the right-hand side, I'm going to go 3 up arrow 5, and the right-hand side comes out to 243. So I know my answer is correct because I checked it. So every problem I took the time to check, and you should do that when you're doing your homework as well as on the test. All right, that's got to be a good stopping point, so I'll just pause it and let you finish this up.